everyone, welcome to the session. So in this particular session, we will talk about the last case of our Masters theorem. What's that case left? When the value of log of a base b is less than k. So far in our previous two videos, I hope everyone already have watched, we have seen the case number 1 and case number 2, where either the value of log of a base b is greater than k or it is equal to k. Now in the last part of the session, we will try to discuss that what will happen when the value is less than k. It's quite simple. Let me try to take one example, and with the help of that, I'll try to demonstrate you. For example, here we are having the value of t of n, which is equals to 2t n by 2 plus, I would say, n square. Now in this particular example, if you will try to find out what is the value of log of a base b, here you are getting the value as log of 2 base 2, which is equals to 1, which is for sure lesser than the value of 2, because the value of k here, as you can see in this function, is equals to 2, right? So in this particular case, this case number 3 will lie, where the value of log of a base b is less than k, right? Now, what is the value of p, by the way? It is equals to 0 here. So basically, when the value is less than k and the value of p is 0, what it is saying? That it's just that theta of n square. So always remember that whenever, without referring the above thing I am telling now, just try to evaluate what is the value of log of a base b and what is the value of k. Whenever the value of log of a base b is lesser than the value of k, what you need to do is that you need to directly just put the value of f of n. Whatever be the value doesn't matter. Whatever be the value doesn't matter. It's just that the value of p should be greater than equal to 0. For example, here instead of n square, you are having n square log of n. For example, you are having 2t n by 2 plus n square log of n. So what will happen? You will again try to find out what is the value of log of a base b. Again, you are getting the value as 1, which is less than the value as 2. So what you are getting the value as directly, you can directly just copy paste the value of f of n here. That's what I want to state here. Here if you will see, it is nothing but n to the power k log of pn. That's what we are getting here as well. You can just directly fetch up the value of f of n and you can directly write it like this, right? Another example, for example, you are having the value of t of n as 4t n by 2 plus n cube divided by log of n. Okay, this is the value that you are having here. Now here the value of a is 4, the value of b is 2. Again, if you will try to evaluate what is the value of log of a base b, it is nothing but is equals to log of 4 base 2, which is equals to 2. Now the value of k is something which is equals to 3. Again, the value of log of a base b is somehow less than the value of k, right? In this particular case also, what you can see is that it is falling under the case number 3. But here the value of p is equals to -1, which is less than 0. So what you need to do is that you just forget what is the below portion it is written. You can directly take the value of n cube. That's it. Theta of n cube or big O of n cube. So it is saying take the value as n to the power k. That's what I am saying here. So in a nutshell, for a case number 3, what you need to do is that whenever the value of log of a base b is less than the value of k, if this is the constraint that you are getting here, what you're supposed to do is that you're supposed to see that what's the value of p. Instead of looking into that also, what you can do is that you can just say order of f of n. Directly you can write. If suppose you are having some number which is -1, the value of p is -1. At that point of time, what you can do is that you can directly skip that negative part and take n to the power k directly. That's the overall idea behind the Masters theorem that we have understood. With this, we have learned specifically what Masters theorem is all about. We have learned how we can get the value of a, b, k and p. We have learned the case number 1, case number 2 and case number 3 in a nutshell with all these 3 videos. I hope that I am making sense to everyone that how this Masters theorem will work. In the future sessions, whenever we are getting a recurrence relation of this green type, we will always try to apply the Masters theorem because this will take a lot of lesser time as comparable to the substitution method. That's the only reason I will apply a lot of times this Masters theorem. So always have this thing in your head. Don't get worried because when you do the practice a lot of times, you have the habit and everything will be in your memory after some point of time. If it's new for you, I will suggest to everyone, practice as hard as you can, okay? The only way to succeed is the practice, right? So if you will practice these questions, take more questions of the recurrence relation, which can be solved using the Masters theorem, try to apply, try to see whether you're getting a correct result or not. Specifically in GATE competitive exam, you will get this kind of questions a lot. So you can refer the previous year GATE questions, which will help you to get a better insight of how we can solve any recurrence relation. Because now, knowledge-wise, you know, it's just the practice that is required, which I suppose that you can do. In the next upcoming video, I will also try to give you some practice set questions, which will help you to check your knowledge that whether you will be able to get a clear-cut idea or not of the complete Masters theorem that we have discussed as of now. With this, happy learning to all. Hope you all are enjoying all these sessions with me. See you soon in the next upcoming session. Bye-bye, everyone.